Next part of the project involves comparison of linear regression model with a decision tree regression model using the California house pricing dataset. First, let's talk about this dataset. The dataset has around 20,640 instances with 8 numerical predictors like median income, house age, average rooms, bedrooms, population, etc. And the target variable is median house value. Next part involves pre-processing the data. No missing values were found to be present in this dataset. All features were standardized using standard scaler for consistency. This data was found to be fully numeric, hence no encoding was required. Now let's go through the most important part of this task, that is comparing the performance of both the models. This data set was modeled using both these linear regression and decision tree. Linear regression achieved an R-square value of 0.6 while decision tree achieved R-square value of 0.73, a substantial improvement. This suggests non-linear and interaction effects are important in house price prediction, which a decision tree captures better than a single linear surface. This model was also tested using a hypothetical example. For a hypothetical coastal higher income record, linear regression predicted the amount to be 325K, while the decision tree predicted it to be 410K. The tree's higher estimate aligns with the real-world coastal premiums, showing its superior ability to model localized effects. Talking about the cross-validation results, again, the 10-fold cross-validation on MSE also favored the decision tree. The NMSE value for decision tree was found to be minus 0.357, while it was found to be minus 0.529 for linear regression. This confirms tree's lower expected error and better generalization for this dataset. So we can conclude that decision tree outperforms linear regression for the California housing dataset due to non-linear relationships and localized effects. But definitely for this dataset, this decision tree model is preferred than the linear regression one. Now moving on to the last part of this project. In this, comparison of logistic regression and k nearest neighbors model is done using adult income dataset. Beginning with the first part, that is the dataset description. This dataset has around 48,000 records with around 14 predictors, and there is one target variable, that is the income, that whether the income is greater than 50K or it is less than equal to 50K. About the pre-processing part, we have already discussed this in the previous part of the project. The key processing steps include replacing question mark with NaN, converting numerics, median and mode imputation, one-hot encoding for categoricals, and standardization using standard scaling. Now, coming on to the model performance comparison for both of these. As you can see, the logistic regression result shows accuracy of 85%, while KNN shows it 83.5%. Logistic regression performs slightly better overall, suggesting the classes are mostly linearly separable in high dimensional space. KNN, while slightly lower in overall accuracy, is more flexible and better at capturing local patterns. Again, this model was predicted on a hypothetical record. I took a record in which the age was estimated to be around 45, having bachelor's degree, spending 60 weekly hours, around $5,000 capital gain. With all these parameters, this points towards a high income record. For this record, logistic regression predicted the income to be less than equal to 50K, which is a false negative, while KNN predicted to be greater than 50K, which seems to be the correct value. This demonstrates KNN's local sensitivity to similar high income neighbors and logistic regression's bias towards the majority class. Talking about cross-validation results, The 10-fold cross validation standard deviations were low for both the models, indicating stable performance. However, because identifying high income individuals was critical in our use case, Canaan's advantage on that specific profile makes it the preferred choice despite slightly lower overall accuracy. So, wrapping up this project, it included first part that outlined an enterprise ML strategy for Starbucks. Second part documented pre-processing for the Austin Animal Shelter dataset. And then next, third to seventh parts presented a range of different ML algorithms on different datasets. Thank you.